All right, then on 12 it says find the exact value requested. First three are double angle formulas, and the last three are half angles. So 12, 13, 14 are all doubles, and then 15, 16, and 17 are all halves. So it's kind of, I will say, it's a little jumbled together, so making sure like you know what it's talking about. So as far as this is my angle, okay, that I'm given, this is where it's occurring, or like the quadrant. So like from 0 to pi over 2, what quadrant are we in? We're in quadrant 1. So that just means that just basically is going to tell you, hey, everything's positive. Okay? And then what... then this is basically your double angle, like of what we're solving, okay, here. So I'm going to just basically piece it together as far as I know it's cosine of 2 theta. Okay, so I know that it's cosine of 2 theta. So like if I would go ahead and write my formula of this one, I have multiple options, right? Of my double angle formulas, I can pick really one of 3 things. It's up to you as far as what you pick and what you do. Okay? On certain ones, like whenever you get to the half angle formulas, you can do, like tangent has 3 options. Cosine of a double angle has 3 options. Okay? You can do whichever ones you want. It's really up to you. The one I'm going to do is just going to be cosine squared of theta minus sine squared of theta. I'm just picking the first one. You could, and I'll write the rest of these. You could do 2 cosine squared theta minus 1. Okay? Or you could do 1 minus 2 sine squared theta. You could do that one. Okay? You have options. Okay? A half tangent angle and a double cosine angle are the only 2 that you have multiple options. Everything else, you've got to run with what you've got. Okay? And you can't change it up. So if it's tangent, then that means I still, just like I did with the sum and the difference angles, I still want to figure out what is x, what is y, and what is r, because I'm going to need it to find cosine of theta and sine of theta. So then whenever I do this, if tangent is 2, remember that tangent of anything is just y over x. So then if I have my 2 values, y is 2, x is 1, I've got to find r. So in doing that, to find r, remember that's just 1 squared plus 2 squared. Okay? So I have 1 plus 4 is equal to r squared. So r is equal to, bless you, the square root of 5. Okay, because I had to take the square root of 1 plus 4. So then from there, I'm going to go with sine and cosine. So if I do sine of my angle, I'm going to have 1 over, because it's, not 1, 2, my fault, 2 over the square root of 5. Now, I'm going to leave it like that for right now, because I'm going to have to square something, even if I don't use it. Even if I don't use sine of theta, I'm going to square it, so there's no need to rationalize it. Does that make sense? Okay? I wouldn't worry about rationalizing any sort of denominator until the very end. Okay? It's going to create less work on you, because if you just do it at the end, you only have to do it once. So cosine then is x over r, so 1 over the square root of 5. Again, from here, once you get sine and cosine of any of your angles, that's whenever you can basically start. Okay? It's like the beginning of everything that you do. You want to make sure you have x, r, or x, y, and r of all of your angles, and then having sine and cosine of all of your angles. Because if you notice, like double angles, sum and difference angles, and half angles all deal with, and even sum to product and product to sum, all deal with sine and cosine. The only one that doesn't is tangent of a sum and a difference. Everything else deals with cosine and sine. Okay? So that's your key, is making sure that you have sine and cosine of every angle that you need. So again, from here, it's completely up to you as far as what you do and how you use it. Okay? I'm going to use the first one. I'll show you all three and show you that they all work. So if I use, I'm just going to go here first. So I'm going to square. I'm going to take 1 over the square root of 5. I'm going to square it. And then I'm going to subtract 2 over the square root of 5 and square that. Well, what's 1 squared? 1. What's the square root of 5 squared? 5, right? Subtract square root of 2, or 2 squared, excuse me, is 4 over 5. What is 1/5 minus 4/5? Negative 3/5. I do the same thing with the, if we go 2 cosine squared minus 1. If I go 2 times, I forgot my theta, my fault. One over the square root of 5 squared. Again, and then minus 1. So 2 times 1/5 minus 1. So 2/5 minus 5/5. What's 2/5 minus 5/5? Negative 3/5. What do you know? It's the same answer. Again, do the same exact thing, but do it with 1 minus sine squared theta. 2 times sine squared theta, my fault. So 1 minus 2 times 2 over square root of 5 squared. So 1 minus 2 times 4/5. Well, 2 times 4/5 is, let's just go 5/5 minus 8/5. What's 5/5 minus 8/5? Negative 3/5. It does not matter to me. Cosine of a double angle, tangent of a half angle are the only ones that you have options. Everything else, you've got to run with the formula that you're given. Okay? It does not matter to me if you use the black one, the green one, or the blue one. As long as you do the math right, you are going to get negative 3/5 every single time. Now, for like 13, where it's a double angle of tangent, you only have one option. You have to use 2 times tangent of theta divided by 1 minus tangent squared theta. Okay? You don't have an option.